Hello and welcome. Today, we're going to talk about one of the most powerful, fundamental tools in any chemist's toolkit, thin layer chromatography, or as pretty much everyone calls it, TLC. So let me paint a picture for you. You've just spent hours running a reaction, and what do you have to show for it? A flask with some clear liquid inside. So did it work? Is your product even in there? Is the stuff you started with all gone? How in the world are you supposed to know what's going on? Well, this is exactly where TLC comes in to save the day. It is the chemist's go-to detective tool. It's fast, it's cheap, and honestly, it's pretty elegant. In just a few minutes, this technique can give you a surprisingly clear picture of your reaction, telling you what you've got, how things are going, and what you need to do next. Okay, so here's our game plan. We're going to start with the why behind it all, which I like to call the Great Molecular Race. Then we'll walk through exactly how to prepare and run a plate, how to read the results, and we'll wrap up with some really crucial pro tips to make sure you're getting perfect results every time. So what is actually happening on that little glass plate? Well, you can think of it as a competition. It's a race between all the different molecules in your sample. And if you understand the race, you'll understand TLC. You know, every race needs two things, right? A racetrack and something that makes the runners move forward. It's the exact same thing in TLC. The racetrack is what we call the stationary phase. That's the thin white coating of silica gel on the plate. And the thing that pushes everything along is the mobile phase, which is just the solvent that creeps up the plate. So who wins this race? It all boils down to one simple property: polarity. Think of it like molecular stickiness. The silica plate is super polar, or very sticky. This means that polar compounds in your mixture, they just love to cling to the plate. They get stuck and barely move. But nonpolar compounds, they're more slippery. They don't care about the plate, they'd much rather hang out in the moving solvent, so they get swept right up to the top. And that difference in speed, well, that's what separates everything. So the whole point of this is to get a really nice separation. We don't want all our spots bunched up at the starting line, and we definitely don't want them all washed away at the finish line. The sweet spot is getting everything spread out right in the middle of the plate. That's when you get a really clear picture of what's going on. All right, enough theory. Let's get practical. Setting up a TLC experiment the right way is honestly half the battle, so let's walk through exactly how to do it. First up, we prep the race course. You'll put a piece of filter paper into your developing chamber and add a little bit of your solvent. Now that filter paper is key. It gets soaked with solvent vapor, which basically stops your solvent from just evaporating off the plate while it's running. Then grab your plate and gently draw a baseline. And I'm serious here, use a pencil. Pen ink will run right up the plate and ruin your whole experiment. Now, that 1 centimeter measurement, that is absolutely critical. Why? Because when you put that plate in the chamber, the solvent level has to be below your starting line. If your spots are chilling in the solvent pool, they're just going to dissolve. The race is over before it even begins. Okay, the stage is set. The racers are getting ready. It's time to spot our samples on the starting line and kick off the Great Molecular Race. Okay, time for spotting. You'll dissolve just a teeny tiny bit of your sample in a solvent that evaporates quickly. Then you'll use a super thin glass tube called a capillary spotter, and you just tap. A light, quick tap on your pencil baseline. Let that spot dry completely, then use some tweezers to gently place the plate into the chamber, pop the lid on, and let it run. And here is a major pro tip. Size matters. You want your spots to be as tiny and as concentrated as possible. We're talking 2 millimeters across max. See, big, wide spots just turn into big, ugly smears as they move up the plate. But small, tight spots give you those sharp, beautiful little circles that mean a perfect separation. You're going to let the solvent climb almost all the way to the top. Then you'll take the plate out, and this part is super urgent. You have to immediately draw a pencil line right where the solvent stopped. We call this the solvent front. It's totally invisible, and it will evaporate in seconds, seriously. And you absolutely need that line to do your calculations later. Okay, the race is over, but there's a problem. Most organic compounds are colorless. So now that it's done, how do we actually see where everybody finished? It's time to reveal the results. So we've got 2 main ways to see our spots. The first and easiest is a UV lamp. It's non-destructive. Most TLC plates glow a bright green, so if your compound absorbs UV light, it'll show up as a dark little shadow. Simple. But if you don't see anything, you have to move on to a destructive method. This means dipping your plate into a chemical stain that reacts with your compounds to make them colored, usually after a little bit of heat. Now, to make this all scientific and repeatable, we calculate something called the retention factor, or just the RF value. It's basically a number between 0 and 1 that tells us exactly how far a compound traveled compared to how far the solvent traveled. It is the key piece of data you get from a TLC. And the calculation? It's super simple. You just measure the distance from your baseline to the middle of your spot, and you divide that by the distance from the baseline to that solvent front line you drew. That simple ratio is your RF value. It's kind of like a fingerprint for your compound in that specific solvent system. Look, everybody makes mistakes when they're learning TLC, so let's do a quick-fire round of the most common problems and how to fix them, so you can level up your TLC skills and get perfect plates every single time. Does this look familiar? Yeah. Instead of nice, tight little spots, you get these long, streaky blobs. This is, without a doubt, the most common problem people run into, and it makes your plate almost impossible to read. And the solution is almost always the same thing. Your sample is way, way too concentrated. The TLC plate just gets overloaded and can't handle it. The fix is so easy. Just dilute your sample. Sometimes you have to dilute it a lot and try spotting it again. You will be amazed at how much better it looks. I absolutely love this quote from a fellow student. It really gets to the heart of the spotting technique. You always feel like you need to press and hold to make sure you got a spot on there. But you don't. A super quick, light little tap is all it takes. Just trust that the liquid transferred. Your spots will be so much smaller and cleaner. So there you have it. This powerful little plate gives us a whole chemical story in just a matter of minutes. It's an amazing analytical tool. But that leaves us with one final thought. How could you take this exact same principle, this great molecular race based on polarity, and scale it up? Not just to see what's in your flask, but to physically separate grams and grams of it. Well, that is the next step in the amazing world of chromatography.